Okay. So this is the second video. In this video we go through terminology of ODE, so more terminology. So in that video we understood what's an ODE. In this video we're gonna go and see terminology of definitions involved in ODE. So first thing that we have to understand about the ODE is the order of ODE. So we say that the ODE is it's an equation that involves the derivative, but which derivative, and we say that derivative with only one variable, but derivative with one variable can be many derivatives. So it can involve the first derivative, can involve the second derivative, the third, the fourth, blah blah blah. So once we are talking about the order of the ODE, we're talking about the highest ODE, not the highest ODE, we're talking about the highest derivative. The highest derivative that appears in the ODE. So we are concerned about the highest derivative that appear in the ODE. Let's take examples, and for taking example, let's see how we can write higher term ODE. It actually can stick it to the board. Amazing. So let's talk about the highest term of the ODE, how to write higher ODE. So this thing means that we actually take the function, if we want to put the function as y and differentiate it with respect to x. We also can write it as function of the function with this thing which is like derivative, differentiate it. We can also write it in this term, which means this is the second derivative of y with respect to x, or we can write it as this thing, and so on. Generally speaking, we can write it as this thing. So this is, we differentiate it n time with respect to the y, and this thing goes to, which means it goes like this, which means you have the function, you differentiate n time, and that's gonna be the function. So this is how it looks like, the derivative. This is how the derivative, and this is n, this is not 2n, this is n. So this is how the derivative is going to look like. So if the equation involves the first derivative, we call the equation as first order, and this calls it the second order, and blah blah, and this is nth order. And when I said it involved the derivative, the first derivative, it involved the second derivative, I didn't say it only involved the first derivative. So the first or the second, the first order, we can think about it as only the first derivative, or the function itself, because that's kind of the zero derivative. The second order, which means it can include the first and the function itself, and so on. Same thing for the nth order. More formally, let's see informally how the function is going to look like. An example of a second order ODE gonna look like this is an example of second order ODE. So we have the second derivative, because we have the highest derivative in the second derivative. So it would be second, and say order mean like the highest derivative. Instead of saying the highest, we have only second derivative. We only have second derivative. We say second order. Instead of saying the highest derivative is the second derivative. Say second order. and ODE because it only include the, it does not include the partial derivative, it only include the normal derivative that you know. This is second order ODE, and if we move the second term, it will become a first order ODE. It will become a first order ODE. And if we remove the second, if we remove the first, and the first order, it becomes a normal algebraic equation. So that's how an equation looks like. If you want to write in a more mathematical form, we can write that that's the last equation. Let's write it again. Let's try something else, or maybe it's the same, maybe it's not, I don't know. I hope it's the same. So we can write this thing as, it's actually, this thing we can write it is actually a function of y double prime, which is the second derivative, function also of y prime, which is the first derivative. It's also a function of y, and in some cases it can also be a function of x. So for example, if we write here as x, we say it's actually a function of this thing, and the whole thing equal to 0, because we can put the x to the left hand side, and call this thing as a function, and then call this thing as equal to 0. So this is the how we can write the ODE as a function. If we want to write the highest, if this is from this we can know this is actually a second order. And if you want to write your like nth order ODE, say okay, this is n, y to the n minus 1, blah blah blah. You have also maybe y, maybe x equal to 0. So this is actually an nth order ODE, and it looks like this. Another thing that you have to know, it's not like has, it's good to know because you're going to know it. If you want to know it or not, you're going to encounter it a lot till you know it. Is something called a linearity or a linear equation. So linear equation is an ODE that's linear, and everything that's like this. So what's everything like this? It's linear in all of the derivative and y. It doesn't have to be linear in x. It just has to be a linear in all of its derivative and in all of its derivative. So for example, this is a linear ODE. This is a linear ODE, but this thing isn't linear, because with this thing we have the second derivative is square. So once we have the second derivative square, it does not become a linear ODE. So this is what's called a linear ODE. And it's important to know when we have a linear ODE. Let's take another example of linear ODE. Another example of linear ODE is the second derivative plus maybe sine of x times y is equal to 0. This is a linear ODE because we don't have, let's go to the y, let's correct this thing and let's see this thing. It's not like y double prime, y second derivative of y square. It's not second derivative, it's not y square. And this thing is also does not occur. So there's no product of y and anything that relates to y. So there's no product between y and the second derivative of y and the third derivative of y. So let's see what I'm talking about. So y double prime times y equal to 1. This is non linear because we have a product of second derivative and something, or second derivative of y and y. And the last thing is autonomous and non-autonomous. Yeah, I pronounced it right. So we have right now, once we're talking about the function y, we usually talk about function y of maybe of x, or y of t, or y of something. Okay? Y of x, y of t, y of something. If this thing does not appear explicitly into the equation, then it's an autonomous. For example, this thing is an autonomous because we cannot see if it's x, if it's t, so it does not appear. And this thing is non-autonomous because x does appear. And now this is kind of not a tricky thing, but you have to understand that if we have a equation like dy divided by dx plus 6 equal to 0, this is also an autonomous. So if we want to understand it more, then if you remember the function that we wrote in the beginning, so we can, in other words, we can write the differential equation as a function that does not involve the independent variable. That's the mathematical definition of autonomous. We can write it as a function that does not involve the independent function. For example, this one can write the function of the first derivative and x to 0 is equal to 0, or just a function of y prime. This is just a function of y prime equal to 0, and we does not have to write x because the function would be the y prime plus 6. So we don't have to write it. But if you want to write this thing, we must write that it's actually also a function of x, because x does involve here and x does appear here. And this is actually, if you want to write this one as a function, then this thing would be a function. This thing will be a function of the second derivative, second function of y and the function of x, and x does appear explicitly here. So those are the examples of autonomous. So right now we have a linear, and three things that you have to understand with the ODE. The order of the ODE is the thing. Oh, yeah.